everybody. I wanted to demonstrate for you what an iodine clock reaction looks like. This happens to be a slightly different iodine clock reaction. This is going to involve some water, some H2O2, which is hydrogen peroxide, some hydrochloric acid, and some Ki. So I'm going to start with mixing the first three solutions together. So here is my 60 milliliters of water. And you'll notice I'm not starting the timer until I've got all four solutions mixed together. Here is my hydrochloric acid. And you'll notice that what I have in here is just a clear solution. And here is my hydrogen peroxide. Okay, that solution remains clear. And to that, I'm going to add my Ki, which is going to be when I start the timer. So I'm going to go ahead and add my Ki, start my timer, and you'll notice that that immediately ended up in a color change of yellow, but I am waiting for it to turn, and it's getting darker and darker yellow. My impression was that this was going to turn dark blue, but this actually the color change this time might have actually been yellow, and it's really getting dark now. It's turning to a dark orange sort of color, and I can keep swirling and swirling here. I kind of expected it to turn dark blue, but maybe my color change was supposed to be dark orange. So we're going to stop that and try that again and see how that comes out a second time. So interestingly enough, you can see that my first reaction actually turned out to be kind of a dark orange color, but when I spilled some of it right here on my paper, which I did not mean to do, you can see right away that it turned my paper a dark blue color. Well, that was interesting, and I'm not going to pretend I know why this is happening. I expected this to turn a dark blue color as well. So we're going to try this one more time and see if we can replicate those same exact results. Okay, so I don't actually know why that color change when the solution ends up spilled on the paper happens, but it's this dark blue color I was expecting to see, not this dark orangish red color that I actually got. But I have replicated that again. In fact, I just did it again without realizing I was about to do it. I apparently have some on the bottom of my Erlenmeyer flask, and when it comes in contact with the paper, it is immediately changing the color, and I mean immediately changing the color to the darker blue color. So weird. We're going to try one more time just to make sure that I didn't just mess it all up the first time. So we're going to go ahead and first thing I'm going to do is I'm going to put the clear liquids all together with each other. So that's the 60 milliliters of water in this case, and then the 20 milliliters of hydrochloric acid. And then to that I'm adding 10 milliliters of hydrogen peroxide. And that makes our clear liquid. And then to that I'm going to add potassium iodide. And I'm going to go ahead and start my timer. And if I were to say that I want to time it until there is a color change, I am looking for there to be a color change. And I am noticing this time that I must have messed something up, because I am getting absolutely no color change whatsoever. So that is part of the problem here, because what actually starts to happen is that if you were doing this in real life, you have to pay attention and label and mark, because all of these are all in the same kind of graduated cylinder, and they're all clear liquids. And once you get them in the graduated cylinder and make the measurements, you can no longer tell what is what. So that's another possible downfall of what might happen. I'm still just crazy unable to explain why this is dark red instead of that dark blue color that you're seeing when I place this thing on or spill it on the paper. So we're going to try that one more time, because I just need to see it one more time. Okay, one last time. We're going to try this out one last time. Okay, so I have my hydrochloric acid. I have my water. And I have my hydrogen peroxide. And those three are my clear solutions. And to that, I am going to add my Ki solution, which will cause the color change. So upon adding, I'm going to click the start button. So adding and start. and I already see a faint changing to yellow. But remember what we had before is we had this dark orange color. And so it's going there, it's going there. And I don't actually know why it's not turning to dark blue for us. That tells me that, am I forgetting something? What is going on? So I'm waiting for it to actually turn to that dark orange color before I start the timer. And we're getting darker and darker as we go along here. For me to be able to stop it and say, there it is. So we're going to give it time to finish its reaction and get that dark orange color. And once again, I'm going to bet that if I spill it on the paper, it's going to turn that dark blue color. But it does take time, as you can see. The idea being that once we actually reach that final color, then we have demonstrated the amount of time it takes for the reaction to occur in which all of the initial concentration of the H2O2 has been consumed.